Today I'm going to discuss a concept called as urban heat island, which my lab has been working on for quite some time, and how it is affecting the electricity consumption in Delhi. So I guess that at least you have heard the term urban heat island. And so it's a very important aspect that we study when we talk about urban climate. So I think I was just listening to the discussion that was going on before my talk. You were primarily discussing climate change related issues. So urban climate is a local phenomenon. So urban heat island is also a local phenomenon that is limited to the cityscape. So when we talk about urbanization, what are we referring to? We are referring to the socio-economic processes that lead to a very high degree of concentration of people in relatively small spaces, and the places where which are typically associated with the manufacturing and service industries rather than the primary sector, that is agriculture and fishing. So urban areas are places of high population density with large scale residential, industrial and transportation activities confined within relatively small areas. So we can visualize a city or an urban area to be just like an organism which draws say inputs in the form of food items, in the form of water, or in the form of fuel and raw materials required for manufacturing activities, and which draws in energy in the form of power. And then the city gives you output also in terms of the waste generated, that is whether it could be a solid waste or it could be a liquid waste, or of course the manufactured goods also. They may enter into the system and or they may go out of the system also. And then you have the emission of pollutants also, that is aerosols, other gaseous pollutants and greenhouse gases. So within the city, from outside, the clean air is entering, and then modified atmosphere which is polluted is going out. So it is like an organism or any other you can imagine any production process or any industry where any industry which draws inputs from the environment and then produces output. But any production process is always associated with no production process is 100% efficient. It is associated with the emission of waste in terms of the solid, liquid or gaseous waste, or even the waste in the form of heat energy. So now urban structures are different from their rural counterparts in building height and materials, their shapes and sizes, etc. That is, generally, if you go to a city center or in Western countries, you have this concept of what is called as the CBD, or the Central Business District. If you go there, like we have our area near the Connaught Place, so where the buildings are generally high-rise buildings, and then the materials that are that constitute these buildings, these also would have very different physical properties in terms of shapes, sizes, and the material itself. They may have different heat capacities. And then within the urban area, we notice that the road surface density is very high. That is, uh, how many square meters of the area is covered with roads out of total. So that value is much higher in urban areas, and so generally the roads are uh, bituminous surfaces which are grayish black. So these also have a bearing on the urban climate, which I'll discuss in a little while. So what happens? So this is a typical schematic diagram which I'm going to share with you. That if you see you have high-rise buildings over here. In rural areas, very few buildings. That is, so in terms of the densities, that is, buildings are located much nearer to each other. They are very compact, and the number is more. And then, of course, you have this paved surfaces within the city, whereas in rural areas, you have lots of soil or vegetation, grass, or anything that is the natural surfaces are there, which allow if rainfall occurs, it would allow the water to percolate deep into the soil in the rural areas, which is not the case in urban areas where most of the precipitation would go as a surface runoff. And then there would be differences in the amount of water that is evaporated from the urban surfaces. So from the rural surfaces, there's a great deal of evaporation because of the porosity of soil. But here we have these pakka surfaces or the paved surfaces, which do not have any porosity, and they don't allow the water also to percolate. So very little percolation. So the evaporation from urban surfaces is much more diminished as compared to the rural areas. And similarly, the rural areas, you have agricultural fields, or even the forests are also there. So lots of transpiration also. So water vapors enter into the atmosphere through transpiration from vegetation also. But in typical urban areas, because most of the space is being occupied by buildings, so less of vegetation and therefore less of transpiration. And then the absorption and retention of heat. So here, because of as I told you, the nature of the materials that constitute the urban structures or buildings, the heat capacities of these materials are much higher, and the retention of heat in urban areas therefore is much greater as compared to the rural areas. So given this background, it would manifest itself into differences in temperature. So this is a much closer look at what a city may look like. This is the photograph of some tropical city in the Southeast Asia, I guess. So if you see that, many things could be noticed over here. You can notice very tall buildings, and then these seem to be much lower elevation, but this is the back lane of appears to be the back lane of these buildings or houses. And we also notice that most of these houses, these split AC units are installed. Okay, notice this, and notice the grayish black surfaces. Also notice the changes, the variations in the colors of these buildings. So this is dark brown or light brown. This is pinkish. So these kind of things you'll witness. So within the cities, because we want to make our indoor environment very comfortable. So there is employment of heating or cooling devices. So in tropical countries like India and other Southeast Asian countries, it is these AC units would be there. In case of temperate or mid-latitude countries, they would be employing the heating devices. So then there is another thing that you can notice in the in this figure. How much of sky is visible? So very less, very narrow slit is there. So this concept of sky view factor is also very important. So if you look at this kind of, this is a parking lot which is relatively open. So here you see that the sky view factor is very high, 0.96. What is the sky view factor? If you make an angle of 360 degree into the sky, then how much fraction of that circle is being visible to you? That is the sky view factor. So the places, open spaces like parks and parking lots, etc., would have high sky view factor, whereas this is a tree-lined street in a city, so you see that less of sky is visible, so the sky view factor is very less. And then this is a street canyon, which I was showing you in the previous slide. So see, this is the only area which is exposed to sky. And this is a traffic intersection surrounded by tall buildings. So this is how it would look like. And similarly, this is the courtyard of a building, which is, this courtyard is surrounded by tall buildings. So very low sky view factor. So urban areas are basically associated with very low sky view factors as compared to the rural areas being more open. Okay. Now, what are the repercussions of these modifications in the urban structures? As I told you, there is reduced evapotranspiration in the urban areas. Then you have high heat capacities of the urban materials. You have multiple reflections of incoming solar radiation, insolation, because of the complex geometry of the urban buildings. So there may be multiple reflections. That is, the incoming solar radiation falls on a particular building, then it gets reflected and then falls on the street or the road surface, and from there it again reflects back and hits another building, and then from that building it again finds its way back to the space or the atmosphere above. So there would be a very complex multiple reflections taking place, and in each reflection there may be part of the incident solar energy that would be absorbed by the material upon which it is falling. And then, as I showed you, the space heating or cooling, so associated with any, whether you are employing cooling devices or heating devices, lots of waste heat would be released, and not just from the heating or cooling devices, but any activity, like say for example transportation activity, from the vehicle engines, heat is emitted into the atmosphere, because when you run the vehicle, the engine gets heated up due to the friction. So again, lots of waste heat is emitted into the urban atmosphere, or any industrial activity also. So there will be emission of waste heat. And then the air pollutant levels, because of the these large scale industrial and transportation activities, a great deal of pollutants are released into the urban atmosphere, which pollute the urban atmosphere and alter the radiative properties of the urban atmosphere. And then, of course, I have talked about the reduced sky view factor. Now, coming back to each one of these and what the impact on, what would be their impact on the thermal environment of a city. So, as we know that evaporation is associated with cooling. So, whenever evaporation of water occurs, there is cooling. Like we observe the cooling in the you have a pitcher or you have wet clothes, and if you go out there in the ambient environment, because of the wind, the water from your clothes may evaporate and you may feel cool. Or even if you're taken a shower and go outside below a fan, you again feel that. So because of evaporation, so evapotranspiration basically results in cooling. So when there is reduced evapotranspiration in the cities, that means that as compared to the rural areas, the cooling because of evapotranspiration in urban areas is much more diminished. The high heat capacity. What is the heat capacity? What do you mean by heat capacity? Heat capacity is like the amount of heat that is required to raise the temperature of an object. So greater the heat capacity, more heat would be required to raise its temperature by 1 degree Celsius. So heat capacities of urban materials are higher than the rural counterparts. So because of the differences in the materials, urban materials. And so this leads to what is called as lots of heat storage in the urban surfaces. Heat storage is there. And not just the heat capacities, the urban materials may be different from the rural materials in terms of thermal conductivity. So there may be use of metals, which may provide very good thermal conductivity. And so storage of heat may occur within the cities. The urban materials may retain more heat as compared to the rural ones. And as I told you, that multiple reflections of solar insolation. So the rural areas would be more or less plain because most of the land use is cropland. So it is a plain surface. So once the solar radiation falls on that plain surface, it is again reflected back, or a part of it is absorbed and the rest is reflected back towards space. But not like urban materials where there may be multiple reflection. That is, the incoming solar radiation falls on one surface, then falls on another, and then on another. So each time there may be some absorption. So again, that would contribute towards to warming. And as I told you, release of waste heat, large amount of waste heat, or we also call it as anthropogenic heat, anthropogenic waste heat. So which I have just discussed. So these also contribute towards making the urban atmosphere warmer. And then high air pollutant levels. These air pollutants would again have warming ability, because many of these may be greenhouse gases, and which will inhibit the escape of the long wave radiation. Now, reduced sky view factor. What is the impact of the sky view factor? The sky view factor, more open is the sky, that is, more visible is the sky to you, much more efficient is the cooling of the Earth's surface. Okay. See, Earth, the temperatures on Earth are basically governed by the radiation budget of the Earth atmospheric system. And so Earth atmospheric system receives energy in the form of solar radiation. Okay. And but it cannot, we notice that on a long-term basis, the temperatures are more or less constant, or they remain within a reasonable range. And the reason being that by and large, our Earth atmospheric system maintains what is called as a radiative equilibrium with the outer space. So we call it as the radiation budget. So while we receive energy in the form of short wave radiation, short wave means the wavelength of the incoming light is shorter, predominantly in the visible region, what we call as the VIB-GYOR. And while the Earth on its part actually loses energy in the form of long wave radiation, that is the peak emission from Earth takes place at a wavelength of around 10 micrometer, while the peak emission from the sun takes place at a wavelength of about 0.5 micrometer. So the difference occurs because all objects in this universe emit electromagnetic radiation, but the amount of radiation that is emitted is governed by its surface temperature. So surface temperature of sun is much higher than that of Earth, and hence, so greater the surface temperature, smaller would be the wavelength of peak emission, and lower the surface temperature, greater would be the wavelength of peak emission from any object in this universe. So all these alterations that I have just discussed would contribute towards making a city warmer than the surrounding areas. And so typically you find that the temperatures within the city center or the city core are much higher as compared to the temperatures in the surrounding areas. So this is what we call as the phenomenon of urban heat island, because this city is like a heat island surrounded by rural areas which are having relatively lower temperatures. So this is a place which is having higher temperatures. So we call it as the urban heat island. So the intensity of urban heat island, that is the difference in these temperatures, the peak temperature and this one, the temperature in the city core and the surroundings may go as high as up to 8 degrees Celsius or even 10 degrees Celsius in some cases. Now, when we talk about urban heat islands, there are different kinds of urban heat islands that we can talk about. We can talk about what is called as the subsurface urban heat island, which refers to the differences between temperature patterns in the ground under the city and those in the ground under the surrounding rural areas. Okay, that is below the surface. We are talking about temperatures below the surface. Then we can talk about what is called as the surface urban heat island. This refers to the temperature differences that occur at the interface of the outdoor atmosphere with the solid materials of the city. That is the skin or the surface of the ground and the equivalent rural area to the ground interface. So what is the temperature of the urban surfaces and what is the temperature of the rural surfaces? So those differences we refer to as surface urban heat island. Then there is something called as canopy layer urban heat island. This basically refers to the temperature differences between the air contained in the urban canopy layer, that is the layer between the urban surface and the roof level. So there is an average roof level of the buildings that you can talk about in a city, and the corresponding height in the near surface layer of the countryside. What is the canopy? Canopy may be in the rural areas. If it is an agricultural land, it may be a crop level height, or if it is a forest, it may be a tree level height, or if it is a village, these canopy height may be different. So the roof of the houses within the village. And then we have what is called as a boundary layer urban heat island, which refers to the temperature differences of the air in the layer between the top of the urban canopy layer and the top of the urban boundary layer. So boundary layer is, you can think of as a lower layer of atmosphere in which there is lots of mixing taking place because of the effects of the rough surfaces present on the roughness present at the Earth's surface. So that is the boundary layer, and that at similar elevations. So in the atmospheric boundary layer over the surrounding rural regions, what are the temperatures? Now, so this is the schematic to show you what these different kinds of urban heat islands. So this is delta T UHI subsurface, that is delta T U minus R, urban minus rural. What is the temperature difference in the subsurface? In the temperature of this urban areas, subsurface of the urban area minus the temperature in the subsurface of the rural area. So that is delta T U minus R. Okay. Then this is the surface urban heat island. So UHI surface. So this is delta T 0 because the elevation is not below the surface, it is at the surface level. So what is the temperature of this surface as compared to the temperature of this surface? And then you have what is called as the UHI UCL. That means what is the temperature in this? This is the lower one, urban canopy layer up to this height, and the urban boundary layer is up to this height. So the UHI UBL, urban boundary layer, would be referring to this. Okay, so these different kinds of urban heat islands are there. Now, how do we study these urban heat island formations? So there are different ways. One is that we can make measurements of temperatures at fixed ground of observation stations, or what are called as meteorological observatories. And these days we have this network of automatic weather stations, so which will provide you the data on several meteorological variables. Then we can make what are called as mobile measurements. That is traverses in the urban canopy layer. That is what we can begin from a rural area, and we can mount these meteorological sensors on our vehicle, and then we drive through the city, okay, and noting down or capturing the differences in the meteorological variables, including temperature, from the city surroundings to the city core. And then we can again make a traverse from the city core to the city surroundings. But these mobile measurements could also be in terms of vertical soundings. So where we have these balloons, or what we call as the radio sounds, so which carry the sensors, meteorological parameter sensors, and capture the these variables at different heights in the atmosphere. But these days, actually, we rely more often upon what are called as the remote sensing techniques, and primarily the passive remote sensing techniques. So the radiometers which are installed on satellite-based platforms, which rely mainly upon the energy coming from the sun, on the electromagnetic radiation coming from the sun, these are basically passive remote sensing techniques. And whereas there may be active remote sensing techniques also, like the use of lidars, radars, sodars, or microwave wind profilers, which may be again ground-based stations may be there, from where we use electromagnetic energy or to understand about the thermal profiles of the atmosphere. So this is the typical. Now I'll share with you what we have been doing in our lab. I'll share with you some of these results. So basically we rely upon, as I told you, the passive remote sensing techniques, which are in these techniques we draw data from the satellite-based platforms. So there are several satellites which detect radiation, the thermal radiation emitted from the Earth's surface, and based upon some algorithms, we retrieve what is called as the brightness temperature, and from the brightness temperature we derive what is called as the land surface temperatures. So satellite-based platforms would essentially give you what is called as the land surface temperature, or LST. While measurements from the fixed ground stations, you will make measurements of, say, near surface air temperature. So remember what you are measuring. So, and when you want to make comparison, you should be aware about what you are measuring. So satellite-based platforms have the advantage that they give you vast spatial coverage. Okay, that is, we can extract the land surface temperature over the rural areas also, and that over the urban areas also. Whereas the ground-based observation stations, these would be relatively sparse. Maybe we may have around 8-10 meteorological stations in a city, maybe generally fewer than that. I'm talking about a city like Delhi, but in other cities, these network of weather stations may be even poorer. And then maybe 1 or 2 meteorological stations in the rural areas. That's all. So these, but what happens that in reality, there are microclimatic variations taking place. That is, the temperature where I live. For example, I live in Jawaharlal Nehru University campus, and the temperature of a nearby place called Munirka, which is just 1 or 2 kilometers away from JNU campus. Now, the temperature of these 2 places may be very different because of the change in the land use pattern. So there may be microclimatic variations also. So, but these meteorological stations, which are fixed in nature, will not give you the information about the spatial variations, how the microclimate of one place in a city is different from another place in the city. So they don't capture these microclimatic variations efficiently. Whereas that is not the case for the satellite, because depending upon what is the resolution of your data, what is the spatial resolution, but we can in terms of spatial variations, we can capture these spatial variations over a reasonably good resolution. And But the meteorological stations, on the other hand, would have certain advantage over the remote sensing techniques. And that advantage is that in terms of their temporal resolution, that is, these may be fixed ground observation stations, may be giving us data at say every hour they are recording, or every half an hour they are recording. So we are getting, if you are interested in how what is the diurnal variation of temperature of a place, these ground observation stations would be of big help. But you can't do the same thing using the satellite-based platforms. Satellite-based platforms may be useful in giving you information about, say, at best twice a day. So these will give you what are called as the snapshots. Say, for example, you must have heard about MODIS data. These days, MODIS has been in news because of this parali burning. So MODIS also gives you the data on thermal anomalies or the fire count data. So these days, I see that even the journalists sitting in the newspaper office, also the NASA has made their platform so much user friendly that even the journalists are showing in their newspapers the fire counts which the NASA website gives. So, but what I'm trying to mean is that this MODIS satellite, for example, may capture the data twice, say at 1:30 p.m. or 1:30 a.m. in the night. Okay. So similarly, but what will happen that they will just give you a screenshot. What is the land surface temperature at that particular instant when you have taken the kind of snapshot of the Earth's surface? And after that, it would be able to capture that snapshot only after a fixed period. Okay. So it depends when is the satellite overpass. In some cases, there may be a 16-day overpass. In some cases, we may get a daily data, but not certainly at the temporal resolution of every hour or half an hour. So this is a typical land. Hello. So this is the typical urban heat island formation over the city of Delhi during the month of November. This is an old data. We have made several observations after that also, but for the sake of this transparency, this is, so this gives you the land surface temperature. As you can notice that this is the nighttime average land surface temperature. So if you see that the temperatures within the city are much greater as compared to those in the surrounding areas. So similar is the case for the month of December, the nighttime land surface temperature in the month of December. Now what we were interested in. Hello. I request you to mute yourself. I think that. Hello. Hello. I guess I am audible. I think some
yes, sir.
Some music. Somebody had
Yes,
played a
sir.
music.
Sir, you are audible.
Yes, sir. Yes, sir.
So please, whosoever is playing the music is requested to switch off that music. I don't know whether this is a music of a mobile phone or deliberate music playing. I don't know. Anyway, so what I have shown you is that the formation of these urban heat islands in the city of Delhi. Now, we were interested in finding out what is the impact of this increased temperatures on electricity consumption in terms of whether it leads to increased energy consumption or not. So I remember I belong to the city of Delhi, and I have born in the city of Delhi in the 1970s and the 60s. Uh, I remember we used to, during the summertime, we used to sleep on our rooftops, and it was a widespread phenomenon in the city because air conditioners were not there, and but still nights were relatively cool. We could afford really sleeping on our rooftops, and nights were relatively cool. But these days, if you uh, uh, notice, uh, there are hardly any people except for the very poor people who uh, don't have any option but to sleep out there in the open because they don't have any covered area. So other than that, you don't find people sleeping on their rooftops. So this is the difference that has happened. So what we did for this purpose, we tried to, we conducted a study, and we divided this entire city according to the districts. So we have these 9 districts in the city, and that is northwest, north, northeast, and so on. And then if we also got the perform the land use land cover mapping of this city. So these red ones are the built up areas. So this is not a very accurate map. This is a fairly old map, but it still captures the urban built up area. So you see the density of the urban built up area within the Delhi, and then these are the surrounding towns of this is, I think, Faridabad, and this is Gurgaon, and this one is the twin Noida and Ghaziabad area. So, and then you have these yellow surfaces as the agricultural land, which is surrounding the city of Delhi. And there are some open spaces also, and fallow lands depending upon the crop cycle. Now, what we wanted to know the effect of the urban heat island on electricity consumption. But now the temperatures that we get from the satellite data are the land surface temperatures. We don't get the air temperatures. Whereas when we employ cooling or heating devices, it is based upon our perception of how comfortable is our thermal environment. So that is based on our perception about the air temperature, not the land surface temperature. So what we did first, but as I told you that the limitation with the air temperature is that you will get only a point data, that is only at certain fixed points within the city. So that is the limitation. So to overcome this limitation, what we did, we extracted the temperatures from the satellite for the pixel where our meteorological stations are located, and we captured the temperature from the ground observations meteorological station. We extracted only those temperatures when the satellite overpass was taking place. So the two things, that is geographically, from the satellite data, we have extracted the data where the meteorological stations are located, and from the meteorological and from the ground station data, we have extracted the data when the satellite overpass is taking place. So we can say that these data are co-spatial and co-temporal, co-located and co-temporal data. And then we plotted these scatter diagrams. between these. So if you see, we got reasonably good, agreement between the nighttime data and the nighttime satellite data and the nighttime ground observation. That is an R square value of 0.93 and so in almost all these plots. These are 4 different stations: Dwarka, DKSS, Bhavana, Narela. All these stations, you'll find that we are getting very good agreement between the land surface temperature and the air temperature. So there may be bias, problems of overestimation or underestimation, but as you can see that we can, the R square values tell us that we can reasonably predict, using the land surface temperature, we can reasonably predict the air temperature. Okay, so this establishes the validity of our method of relying on the land surface temperature data extracted from the satellite. And then we computed the urban heat island intensity for various districts of Delhi. That is, in this, what we did, that we extracted the land surface temperature of a particular district, and we compared it with the land surface temperature of the surrounding rural areas, the average land surface temperature of the surrounding rural areas. So as you can see that our, we did the seasonal analysis. So few things that you can notice is that the urban heat island intensity is always minimum in the rainy season, the monsoons. Why? This is because of the prevalence of clouds. So whenever the sky is cloudy, now the clouds are not going to differentiate between urban and rural areas. So generally during the monsoon season, the entire sky is overcast. Hello. Entire sky is overcast.
Yeah.
And what happens is that whenever the sky is overcast, the clouds act as a sort of greenhouse gas. They don't allow the long wave radiation to emit from the Earth's surface, to escape from the Earth's surface efficiently. So the urban-rural differences in cooling, nighttime cooling, are much more diminished in the monsoon season. So, and hence the urban heat island is not very well developed in the monsoon season. But if you compare to that, if you see the spring season, when the sky is absolutely clear, so whenever the sky is clear, that favors the formation of urban heat island. Whenever the sky is overcast or cloudy, that means that urban heat island formation would be weaker. Similarly, depending upon the wind structure, if it is too windy, then there will be lots of mixing of the rural area air with the urban air, and the heat island would not be as well developed. But when the conditions are stagnant, that is, the wind speeds are low, the heat island would be well formed. Okay, so now in terms of spatial variations, you see that the temperatures within these central districts are much higher. Central and east district, where the urban built up area density is much higher. So there the urban heat island intensities are maximum, these red and gray ones, in all the seasons. And if you look at these blue and the green ones, so this is the green one southwest and the blue one is the northwest. So northwest and the southwest districts, if I go back to the previous slide, northwest, so this is the I think the southwest, and this is the northwest. So you see that these are the only two districts where still which have rural areas, and lots of agricultural activities are still taking place in these districts, and hence you see the urban heat island intensity is much less in these districts, southwest and northwest of Delhi. Now, this is the plot which shows the net electricity consumption per capita, the red one. And the black one is the land surface temperature, nighttime land surface temperature. Now, if you look at this red plot, and below you have this blue one is the net electricity consumption, but this is not the net electricity consumption per capita. If you look at this blue trend line, this is slightly rising. This is because of the increase in Delhi's population. The net electricity consumption is increasing. But if we divide it by the total population, then this becomes the red line, which is almost horizontal. So that increasing trend is now missing. So this is per capita. And if you look at this nighttime land surface temperature, this is also a slight decreasing trend is there that we are observing. Now, these peaks, if you see, whenever the land surface temperature is high, this black one, you see these peaks, how well they are matching each other. This is the land surface temperature, and this is the net electricity consumption. So whenever the land surface temperature is more, the electricity consumption is also more. Whenever the land surface temperature is less, so how well their patterns are matching, that is what I wanted to show you. So using this, we computed the net electricity consumption per capita for each district. That is the average annual net electricity consumption. In terms of that, if you see the in terms of the average net electricity consumption, that is this dark one, you find that the northwest and the southwest are more. Why? Because this is the net electricity. These districts are very large, so their populations are also larger, so the net electricity consumption is more. But when you divide it by the population of each district, the picture gets reversed. So you get the central district, the net electricity consumption per capita is the highest, and which is then followed by the other districts, southwest and the west and other districts. Now, if you look at the this plot, here we have shown the agreement between the electricity consumption and the temperature. And temperature, different kinds of temperature, that is the air temperature as well as the land surface temperature. So this red one is the minimum temperature, blue one is the mean temperature, green is the maximum temperature, and this one is the land surface temperature, black one is the land surface temperature. So if you see that the best agreement we are getting from the land surface temperature, that is 0.8883, that is the R square value, and in the air temperature we are getting the closest in the mean and the minimum, the red one and the blue one. The daytime air temperatures is still good agreement, but not as high. So the reason being that why we are getting this slightly less agreement between the ground observation data, temperature data, and the electricity consumption is that the electricity consumption is for entire Delhi, whereas this minimum temperature, maximum temperature is only for the submerging station that we are taking. So that may not be representative of the entire city, but the land surface temperature that we are plotting is for the entire city. So you are getting much better agreement. And then what we did, for each district, we plotted these scatter plots of land surface temperature versus electricity consumption, and we obtained these regression equations. And using these regression equations, we computed what is the difference in the, suppose if we eliminate the urban heat island intensity for each district, that is, for each district we had computed the urban heat island. So if we consider the land surface temperature of each district to be the same as that of the surrounding rural area, then what would be the electricity consumption of that district? So that shows that this is how during the month of winter, you see that the without UHI, electricity consumption is much higher, because the urban heat island formation would help reduce the electricity consumption during the winters. Because winter, if the city temperatures are warmer than the surrounding rural areas, we require less of cooling devices. Okay, so you see that these curves are crossing during the winters, but during the summer, which is a major period, the summer as well as the monsoon period, you see that the how much is the excess consumption, energy consumption. In each of these curves, you see lots of gap between the green one is the without UHI and the red one is the UHI. So with this, we computed the annual increase in the total net electricity consumption for each district in terms of percentage, and this we translated it into the in terms of monetary value also, and in terms of gigawatt hours. So from 2012 to 2013 to 2016 to 17, so increased consumption in gigawatt hours is 109. How it has increased? So for various districts, central, east, and northeast district. So overall, we then translated that, suppose we employ the mitigation effects. If you see that in the previous curve, in the previous one, these are the gigawatt hours. So 12, 13, 261 gigawatt, 215 gigawatt, and so on. And if you compute these totals, average figures for 2012 to 13, this is how in terms of gigawatt hours. Okay, so the total now in terms of savings, suppose we were to employ urban heat island mitigation devices, then what would happen? How much of energy we can save? So we use the same equations to estimate what would be the energy saving in each of these districts in terms of gigawatt hours, and then taking a flat rate per unit electricity, we translated that into monetary terms in millions of rupees. So you see that the annual economic benefit for the entire city of Delhi, it works out to be somewhere around 1.19 billion. This is in millions of Indian rupees, 11983 millions of rupees annually. This is for annual economic benefit. And if we reduce these by employing the mitigation strategies, if we reduce the urban heat island intensity by 2 degrees Celsius, then our savings in terms of electricity would be equivalent to around 17,000 million rupees per annum. And if we translate that into per square kilometer or per capita, then for 1 degree Celsius, each person in the South District would gain 341 rupees. Each person in the Southwest would 950 rupees. Each person in the Central District would gain 2,407 rupees, and so on. And this is for 2 degrees Celsius reduction in the urban heat island intensity. So what are the mitigation strategies that we can employ to reduce these heat islands? We can make use of what are called as the cool roofs by one simple strategy is making the color white, because the white color reflects more of the incident radiation, as you can see over here. So this roof is going to be much hotter as compared to this roof. So this is the cool roof. So this reflects around 80%, this reflects around 20%. So another practice that may be employed is what are called as the green roofs. So where the rooftops of these houses are made green. Because of these green roofs, the roof doesn't get heated up because of the incoming solar radiation, and the indoor energy expenditure for cooling goes down. So that is also another strategy that is adopted. And then you can also have lots of green spaces within the cities, like green pavements. These will also help ameliorate the heat island effects within the cities. So, and then another one is that changing the urban geometry. So if you change from this kind of geometry to this kind of geometry, the intensity of urban heat island would be much less. So as you can see, these red colors means this kind of geometry is associated with lots of heat island. So this is all I wanted to discuss with you. Thank you so much. And if there are any questions, you are most welcome to interact with me. So now I am. Should I continue sharing? If anyone wants me to go back to previous slide, or should I stop sharing?
Sir, you can put like this. No problem, sir.
Okay.
So thank you very much, sir. Once again, as we all know that climate change is one of the today most complicated issue. It has many dimensions and it has a global issue that is felt on a local scale. So reducing electricity consumption has emerging as a key area of concern. According to the National Mission on Sustainable Habitat of Government of India. So among the Indian city, Delhi electricity consumption has the highest. So sir has discussed the UHI for the Delhi region. So I would request the participant to raise your hand and directly you can ask the question to sir if you have any doubt or anything you want clarification. So before they ask, sir, there is a in our chat box there are some questions. So
okay.
I would like to read out and
right.
Yeah.
Sure.
So from Anisha, he's asking, what is the current status of UHI study in India compared to other country? That is first question. Second question is, what policy initiative can be taken by government agency to minimize UHI effect on electricity consumption? And the last one is, what initiative can the government take at the personal level to minimize UHI effect on electricity consumption? So these are the three questions, sir, you can ask. So in the meantime, I would request the participant to ready for the question. Thank you.
See, I would put the last two questions in a similar category. And the first question is regarding the status of UHI studies in India. To be honest, the UHI studies in India were fairly limited, though you can trace back some studies way back in the 80s, which are based on the ground observational data or mobile traverses. But these were very limited these had very limited usefulness. But the UHI studies in India have actually started picking up, say, from 2005 onwards, 2007 onwards. Some studies you can find out, and then within Delhi, myself and Professor Manju Mohan from IIT Delhi, we too have been working on these urban climate related issues. And so, in fact, I have not shared with you another aspect of Delhi's UHI, that I was the first one way back in 2012 to report that I have actually right now shared with you the formation of urban heat island during the night time. But if you look at the phenomenon during the daytime, uh, in certain seasons, rather than the heat island, we get the cool island in Delhi. Okay, so I was the first one to report this in our country, and but now it is more or less established. So in the beginning, there were a few studies like my study and Manju Mohan's study, and uh, uh, there's one Javed Malik or Atikur Rahman. I'm forgetting, from Delhi University Geography Department. I think they had also done some UHI studies, and then a few studies from Indian Institute of Remote Sensing also. But after, from 2010 to 2020, now there are a lot more studies that you can notice. Many other workers across the country have picked up these studies, and you can now get studies over Mumbai and other metros also, and even some small towns also. So studies on research on UHI has now picked up in India, but still not at the stage where it ought to be, but much better than before. So in 2000, around that period, around 2008 to 11, I think myself and Manju Mohan were the only two working continuously on this aspect. But now lot many people are there. Okay, now coming to the second one, that what initiative the government can do to regarding. Government already has the this national climate mission also, and uh, national action plan on climate change. So, and now we have this smart cities project also. So in all these projects, actually some of these components are implicit. So, but specifically, as I had told you, that we can possibly employ some of these techniques, mitigation strategies that I have just discussed. So uh, this is the simplest that we can do at individual level, that painting the rooftops as white, and even the building structure, the color of your walls of the houses. So if it is lighter color, the reflection would be more and absorption would be less. So such things can be done. And then at the architect level also. Plus, when you are talking about the smart cities project, so the future urban areas that we are going to design, we must take into consideration all these aspects, and these are actually being discussed at the policy level, at the governmental level now. And uh, but to be honest, there are so many variables in a country like India, but some of the policies, even though these policies exist on paper, but when it comes to translating them at the ground, uh, there are so many variables that these policies don't get translated to the ground in their full spirit. But I think the government is very well aware and moving ahead in terms of attaining sustainability, in terms of energy consumption. And now most of you must be aware that uh, the government of India is going to, embrace the uh, policy of less reliance on fossil fuel consumption. And say, for example, in the transportation sector, government has already opened up the segment for electric vehicles. So, and then the National Solar Mission also is a very big effort in reducing our reliance on the fossil fuels. So I think the government is very much aware, and all these aspects. In fact, when you talk about the climate change phenomenon, at the IPCC levels also, these aspects get discussed, because it is predicted that the by say 2050, a reasonably large percentage of human population would be residing in cities. So urbanization is a phenomenon you can't escape, and hence urban climate is very, very important. And urban climate also uh, has linkages with the global climate. So I hope I have addressed your questions. Any other questions now?
Yeah.
Hello, sir. Hello.
Yes.
Yes.
Sir, for a nice and informative presentation. So my question is, the urban heat island. Also, the phenomena is directly, as you said, that it's connected to the urbanization and urban development.
True.
Yeah. The problem is that the concept of development, how to reduce the heat and the progress and development. So we, the government itself, also push for rapid growth and rapid development and rapid urbanization strategies. So in this context, how can we implement the strategies to reduce the urban heat and those problems?
Right. See, the strategies have to be multi-pronged. One is that the government is, talking about the smart cities project. So in the smart cities project, all these green buildings and green roofing, these architectural principles creep in. The other aspect is more on the concept of development itself, where probably our focus is still lacking, and that is very, very important. This is in my opinion, we should be looking at stopping the migration from the rural areas to the urban areas. So what is happening these days, that people from rural areas or small towns, they migrate to big towns or cities in search of good education facilities, health facilities, and employment. So if we address the issues of education facilities and health facilities, making it decentralized and making it more accessible to the rural areas at their own places, rather than everyone thinking of taking admission in Delhi University for higher studies. I know that Delhi University draws students from all over the country. So rather than those students thinking of coming here and studying, if the quality of education improves, and similarly the quality of health facilities improve, so these would be very big, of very big help in stopping the migration of people from rural to urban areas. So because what happens is that even if you plan your cities well, you may plan the city say, for example, say 1 billion population or 2 billion population, but then the population rises further, and then your entire planning goes haywire. So the idea behind smart cities should be accompanied with the parallel development strategies in the rural areas. And if we adopt that, then I think this rural to urban migration would be inhibited to a great extent. And then our cities as well as the rural areas would become sustainable.
Sir, hello.
Yes.
Sir, as you said that to contain the migration and all those things, but the problem is it possible to limit the migration from rural to urban? Because our rural areas mainly is most backward in terms of the infrastructures. As you said that the problem of education
That's
and
what.
access, the quality of
No,
education,
I think it is. It
access,
is.
all
It is
these are
certain.
even in the social problem also.
I agree. I agree.
The
These
question
are
of
the
equality.
problems our country faces, but I think this is entirely possible. It just requires political willpower to address these pressing issues. And not that our country has not moved forward in this direction, but in some cases, the environment, the changes have taken place for the worse. For example, if you go particularly to the talk about the rural areas in some states, you will find that there used to be what are called as the common property resources. Each village would have a common forest and a common arable land for their animals to graze. But all such common properties resources have now been have vanished from the villages. I can say that especially with authority uh, about the villages in Haryana, because I originally hail from the state. So we don't get such common property resources as we used to witness when I was a small child. So uh, but to say that it is not possible would be, I think, a very, very pessimistic view about this entire issue. I still feel that it is possible to address these issues. It just requires, political willpower to address such issues. That's all.
Yeah, I think
Uh,
Okay, okay.
we need a
th-
cooperative effect from state and central government.
okay, thank you very much, Dr. Vivek Abraham. Now here, sir, there is one more question related to the one which Dr. Vivek has asked. It's from Sutir Dalal. He said that developed country have high tower building like in Dubai, UAE. They are shifting to environmental having high UHI intensity. So is it better to have high rise building with mitigation strategy to meet the demand of urbanization? Here also, government is giving permission to high-rise building to accommodate population. So this is from Sutil.
Yes, see, very nice question, Sudhir. Actually, the concept of high-rise buildings is basically talks about the high-rise buildings should be accompanied with lots of open spaces. But unfortunately, when you see the high-rise buildings around the world, it doesn't happen so. Even though people talk about high-rise buildings with lots of open spaces, but practically speaking, it doesn't happen so. But the places where the population densities are the population pressures are higher, of course, they are going about in such a fashion. But there also, if the high-rise buildings are closely spaced, certainly they will contribute to the formation of urban heat island, and these would have a bearing on the local circulation patterns also. There have been studies conducted which talk about the impact on precipitation over the urban areas, say due to some approaching thunderstorm, how the urban area affects precipitation. What is the precipitation in the upwind region, and what is the precipitation in the downwind region, and what is the precipitation on the city? So there are variations in that. So the ideal thing to have is that we reduce our population pressures. So when the population pressures are less, then we won't be requiring these high-rise buildings. So, but that is one concept which people have floated around, because what will happen that if you have high-rise buildings and with lots of open spaces, that is, if there are lots of parks around, then the paved surfaces would be much less. As if you, for such a high population, actually, if you construct dwelling units all across the city, the entire city would be uh, covered with paved surfaces or pakka surfaces. So there very little percolation will take place when rain occurs. But instead of that, if we have high-rise buildings with lots of open spaces, I'm emphasizing that it requires you to have lots of open spaces. If you have lots of open spaces, then uh, that means that the high-rise buildings are not very close together. So then it would be desirable, perhaps a desirable thing to have, because you are not altering the basic structure of that rural area to such a large extent as you would have been done if you had constructed the dwelling units all across the city.
Okay, thank you very much. One last question, if anyone want to ask.
Frankie, can we wind up now?
Okay,